Okay, so this may seem like this was a stupid activity, but it is supposed to actually help with something. So hopefully you performed, as you performed this, you kept track of the time. How many of you started the time when you started making them? Okay, good. That would be 1, 2, 3, 4, 5 people out of 30. Okay, well then that's mostly pointless. But those 5 that did, what was your rate? 1658. So divide that by 20. So 0.85 widgets per minute. You okay with that? Or no, minutes per widget. Minutes per widget. All right. Any other group do theirs, or was that all the same group that timed it? Okay, divide that by 20. All right. Okay. Tim, you guys were done fast. Did you time? Thank you. Gosh. It's okay.
They were like, wait, were we supposed to time it? They never really said like start your timer.
Well, I don't feel like we're at a place in your life where I have to tell you to start. But maybe we are. I mean, you're in one of the hardest classes in the school. You should know how to track your own time. I'm just saying.
I think it started already.
All right. So, well, we have 2 groups that did. All right. Now look, one had a faster rate than the other. So how did you guys get it done so fast? They had 3 people. Okay. Anything else? Hey, please quiet. What? Okay, clearly defined roles. Okay. Who went super slow? What took you guys so long? What was your role? Oh, you were the annoying part? Okay, well, that's important. All right, this is going super well so far. Well, let's think about this. Make a statement about how you could have sped this process up. So what's one way you could have gone faster? Anybody? Okay, if we had more staplers, RIP, more scissors, all right, more hole punches, right? Okay, so for each of your group, one of the steps was probably the slowest. Now don't name the person, name the step that took the longest. Signatures, okay, what else? Waiting for the stapler, waiting for the hole punch. So for each group, you would list what took you the longest. I used to do this a little bit different, but it took all day. I would put out like 10 total things and we'd have a draft. And some groups would end up with like nothing but a nail. There's a desk over by that wall that has kind of holes in it. Anyone see that desk? Those are from a kid hole punching with the nail in this activity, because that's all they had. And they used to have to take staples apart by fingers and then put them through and hammer them down. And that took forever trying to find the nail. It's a classic. Here it is. So a few years ago, this was the only thing a group got. And then I was like, well, that damaged my desk. So maybe a bad idea. I thought everyone did.
You're the only one.
I'm the only one. We used them forever ago to mark the marks for our long jumpers. If you know, you know. For long jump. Our long jump ramp here was in the grass, and we'd just drive a nail, and it lasted all year long. But now you can't really drive a nail through our cement. Anyway, moving on. Okay, for those groups, usually trying to staple something with your fingers took the longest part, right? All right, but we have what we call staplers. And in chemistry, A stapler would be an example of a catalyst. Until today, I had never used up a stapler in this entire activity. I've used the same staplers my entire career, in fact. But we were blessed today that our catalyst was used up. Okay, yes.
Is there a way to figure out, like, so after we did the whole thing, is there a way to figure out how each, like, little thing is stapling took how much time?
Just if you kept track of it, you'd have to start your timer and stop it when you were done. He's not looking at me, but no, not after you're all the way done. Okay, so if we look right here, this sentence, what was your rate determining step? It was your slowest step, right? We still got someone signing right here. That took a while. So you're not the only one, I'm sure.
Yeah.
But each one of these, it was steps to get it done, right? In fact, there were 1, 2, 3, 4, 5, 6 steps. One of these was the slowest. So a couple of you said it was finding the stapler. So that would be your rate determining step right there. Okay. Some of you might have thought the cutting took the longest. Some of you waited for a hole punch. Some of you thought the rate determining step was this, how long it took to actually sign your work. So when I was a kid, I had the worst job ever. And I worked at a water bottling plant, and I literally just lifted gallon jugs of water from a machine and put them in a box and shoved them through a taping machine. It's pretty fun. I did the math one day. I lifted over 2 million pounds of water a day. Yeah, not all at the same time. That'd be amazing. I was really buff back then. But no matter how fast I lifted those jugs of water and put them into the box and shoved it through the taper, what controlled how fast I got done? Any ideas? How fast they came to me. The conveyor belt was the rate determining step of when I went home. All right, because I could grab 2 at a time, and you just kind of drop them in, fold, shove. Like I could do it in my sleep right now. I did it all summer long, all day, every day. And then you'd just have to wait. And you're like, man, I could get so much faster if this conveyor belt moved faster and filled it up with water. But it didn't. There's always a slower step. In this process, you had a slower step, and we call that the rate determining step. What's that? It was 1 gallon jugs of spring water that you then put into a box of 4. And then you ship that to the store and they unbox it and they put it on the shelf. Yeah, it was called Rocky Mountain Water. It's Mount Olympus Water's competitor, and it tastes way better. On Thursdays, we did the 2.5 gallon like rectangle ones. And oh, that was rough. My body killed after Thursdays. And this is where I learned, this doesn't need to be on the video or any of science, but this is where I learned to buy generic. Because we would bottle Rocky Mountain water from like 6 a.m. to 1. And then we go to lunch and we come back at 1:30. And while we were at lunch, they changed the labeler to say Western Family. So all of a sudden the water got $2 cheaper because it had a different sticker on it. And I was like, generic's not that bad of an idea. It's the same thing, different label. Okay, so what this activity is supposed to enforce to you is that there is always a slow step. We call it the rate determining step, and we can speed that up if we use usually some sort of catalyst or mechanism to speed that part up. So like the stapler or the scissors. Could you have torn the paper? Yeah, for sure. Like I'm a pretty fast tearer. I bet I could tear paper faster than you can cut it. Yeah, so because you could go faster than you could cut it, right? There was no requirement that these look pretty. And so I'm sorry that I called you out about your square one instead of rectangular one. I'm rude like that. Okay. Anyway, the catalyst is the thing that helps the process to happen faster. Easy enough? All right, everyone get full credit for that. If you feel like turning it in, you can, but I'm not going to make you. All right, so let's talk about chemistry and about multi-step reactions, the rate determining step, which we call the slow step, and how that leads to the overall reaction. Sound good? This process, if it clicks, kids really enjoy it because you're like, oh, that makes a lot of sense. If it doesn't, you're lost the whole time. So welcome back. You've been there before. That was rude. Yeah, I just need one. That would be how I grade you. Yep, I'll grade.
I promise that's my signature.
Mhm. I think the last one turned in is probably the neatest one. Yep. It's Rebecca and BB.
What's the second neatest one? That's what you say ours.
This one's close. Preston and Olivia. This hole punch doesn't get all of it, so that one's out. This one's not a rectangle, although it's a very cute square one. Tim's not straight. This one's torn. That's out. SMJHAA. That one's a pretty good one. They're all pretty good, I'll be honest. Okay, here we go. Reaction mechanisms. So this whole thing of ideas that there's steps, it's called the reaction mechanism, the way that it happens. Are you okay with that? So the order of the reaction can give you clues about the mechanism, and the mechanism can give you the order of the reaction. What's wrong? With what? I got hit anyone on the head. No one's going to get a concussion from that anyway.
Do it.
Oh, multiple bounces. All right. I guess the Bensons are probably all looking at dead bodies. Nothing's weirder to me than the cadaver lab. Ugh. And then they go to a buffet after. That just seems so wrong.
Very.
Oh. You get ribs? Okay, that's disgusting, Tim.
Before or after?
All right, so here we go. Think about the following mechanism. So we have A2 plus B2 goes to R plus C, A2 plus R goes to C. What? Okay, I got this. This is considered the slow step. Now, how do we know that? We have no idea except for they tell us it is. You okay with that? So once the first step here happens, the second one happens pretty quick. So since this one's the slowest one, we call it the rate determining step. Are you all right with that? And the rate determining step will give us the rate law. If you look right here, you have A2 and it's reacting with B2. You all right with that? I'm going to write that different. So I have A2 and B2. Are there more in the slow step? Is there more than one A2 or more than one B2? Everyone look at the screen. Is there more than one of these in the top? Nope. So we would put a 1 and a 1. We don't care about the second step because it happens so fast that it's not part of what we call the rate determining step. So when we write our rate law, we find anything in the slow or above it, and we include it in the rate law. Okay, so I know you're like, well, this doesn't make any sense. Well, it will, I hope. If we were to switch this around and we were to say that the top one is the fast step and the bottom one is the slow, then something would change about this. The first thing we would do is get rid of R. R has a name. Anyone know what that is? It's an intermediate. It's an intermediate. It was produced and consumed in the next step. You all right with that? So that's an intermediate. And so then I'm left with these three reactants. yes, I know that C is over here, but it's a product and our rate is determined by our reactants. So if the second one was slow, I would include everything in the slow step and anything written above it in previous steps. So if the second one was the rate determining one, we'd have rate equals K, and we'd have A2, but this time, how many A2s are there? 2. And how many B2s? 1. So this mechanism and knowing which is fast or slow will give me the overall rate law. We all right with that? Now, it kind of goes both directions, but not perfectly the other direction, because we don't know for sure. Like we would know that at a minimum, we'd have 2 A's and 1 B, but I wouldn't know if the first step was like A and A, or I should say A2. All right, or A and B2, or B2 and A2, or whatever. But I would know the parts. I just wouldn't know which order they were in yet. Okay, so when we do this process, we find the slow step and eliminate any intermediates. All right, that's something that's produced, a product in one step and a reactant in the other. So we cancel those out and then take the reactants in and before the slow step, and that will be the rate law. Never include anything after the slow step though. So far, kind of all right. So let's look here. So this is the slow step. So I want to know the rate. The first thing I'm going to do is eliminate any intermediates, which is what? Tell your partner. It's this single O, right? Okay. Then I look at any of the reactants that are left, and they are O3 and another O3. You with me? So I know one of the reactants is O3, and how many of them are there represented? 2. You all right with that? Is there any other reactant? No, there is not. And so you might be thinking, well, where's this stuff? Well, it's in the reaction. 2O3 goes to 2O2 plus, or sorry, I guess it's 3O2. I just got to look at it and yet just add them. Okay, this is the overall reaction. Now we know the rate law because we knew the mechanism was this process. Fair enough. Okay, now what would be different if this was slow and this was fast? Tell your partner what would change. Okay, good. So O3 would just be a 1, right? Because we wouldn't include anything after the slow step. We would only find the reactants in the slow step, nothing below it. Thumbs up if you're okay with this so far. Okay. So we have slow here. Will you write the rate law for me? All right, we ready? So first off, I'm going to get rid of any intermediates. It doesn't actually even matter here. I have NO2 here, right? And NO2. Why does an intermediate not really matter right now? Okay, because the top's the slow step anyway, and this is a product. So it's okay. We can still eliminate it. but I'm left with these two reactants, right? So my rate is equal to K times O3 to the first and NO to the first. We okay with that? Go ahead, Seth. No. I know you see it right here on both sides, right? But it wasn't, it's not produced as part of the reaction. It was introduced as part of the reaction. It has to be on the product side. Mhm.
Something that exists in the middle, but not at the end.
Right. Yep. Okay. Because I don't include anything underneath the slow stem. You all right with that? Okay, this one. This is how you'll see it often. It might look confusing, but this is just the overall reaction. You don't have to like stress about it really to find rate. It's still just these two things. All right, hopefully went fast. Our rate is equal to K. The top is the slow, so it's really just simply N, whoops, why did I start with O? NO2Cl, and it's just one of them, right? Okay, now, oftentimes they won't give you the overall, but they'll ask for the overall based on this information. Okay, so look at this. If it didn't give us the overall reaction, but it asked for it, we could still do it. We would get rid of our intermediates, which would be the lone CLs, right? Anything else produced and consumed? Nope. So we would end up with two of these, which we have, and then my arrow, and I'd have two of those and one of these, two of those, one of these. You with me? So we can get all these things from each other. Okay, let's do, we haven't had a second one be slow for a little bit. Let's make this one slow and this one fast. What would we get? The only difference is you square it now, right? Because there are two NO2Cls that have to combine for this reaction to happen by the time we get to the slow step. We all right with that? Okay. So many of them. Here we go.
We just ignore the backward arrow.
Yep, it doesn't matter. This is just showing you that it can go either direction. And if we did math, we'd have like 7 or 1/7 if we had to do that math. We'll learn that pretty soon. Chapter 15. Okay, what do we think about this? Are we all right? All right. Let's see if I have one. Ooh, catalyst, enzymes, test review. What? What? We're there, my friends. All right, we got 1:20, so we'll call it good for right now.